we're going to factor perfect square trinomials. Now, they're called perfect square trinomials because you're literally taking a binomial and multiplying it by itself to get this pattern. If I take a times a, I get a squared. If I take b times b, I get b squared. The middle term will be ab plus ab, which is 2ab. So it literally ends up in this pattern. Now, the only thing that changes is if I have a minus sign here, I will have a minus sign here. So let's take an example. If I do 2a plus 1 squared, that literally means 2a plus 1 times 2a plus 1. 2a times 2a gives me 4a squared. 2a times 1 gives me 2a. 2a times 1 gives me 2a. And 1 times 1 gives me 1. So this is 4a squared plus 4a plus 1 when you put the middle terms together, which are like. So if you notice what happens, truly happens, is I take this term and I square it, that's the first term. I take this term and square it, that's the last term. The middle term is going to be equal to these two multiplied times 2. Always whatever these two are multiplied times 2. Okay, so if I am doing a perfect square trinomial and I'm trying to factor it, what I literally do is I look at the first term and I do x squared, I square root the x squared. Square root the first term, so when I square root x squared, that gives me x. Square root the last term. The square root of 9 is 3. Then I take these two, 3 times x, and I multiply it times 2. 2 times the square root of the first term times the square root of the last term. And that gives me 6x. If that happens, and it does, this is called a perfect square trinomial. And it's simple to factor. You just do x plus 3 times x plus 3 and put it in parentheses with a square. Now, remember, I've kind of typed this out. It's very, very important. The last term must be positive since you cannot take the square root of a negative number. So be careful. If you ever see one with a minus sign here, it's not a perfect square trinomial. All right, let's look at this one and see if it is a perfect square trinomial. Remember, you just square root the first term, that's x. Square root the last term, that's 5. And then you look to see if the middle term is 2 times the x times 5, and it is. This is a perfect square trinomial. Now, the reason this is here is because you can factor perfect square trinomials just like we've been factoring all other trinomials by writing 25 in the top of the x, 10 in the bottom of the x, and looking for two factors which add to 10. And it's going to be two factors of 25 which add to 10 are 5 and 5. And you can see that it's perfect square trinomial here because you end up with the same factor. So that's the other alternative. So if you don't remember perfect square trinomial, it's really okay. You can still factor it using the x method. All right. The square root of y squared is y. The square root of 64 is 8. And then you check the middle term. You must check the middle term. Because just because you have a perfect square here and a perfect square here does not mean that the middle term is going to be 2 times these two. It is in this instance. But if you had one that was not, then that could not be factored as a perfect square trinomial. You'd have to check it out with the x method and see if it could be factored. All right. Square root of 16x squared, 4x. Square root of 9 is 3. Check the middle term out. Make sure, and that is 24x. That works. Come down here, same thing. The square root of a squared is a. The square root of 36 is 6. 2 times a times 6 is 12. I'm going to skip these examples because I think you can see them just fine on the notes. And we're going to move on. All right. Now what you want to check out is to see whether or not that these trinomials are perfect square trinomials. Notice what I said earlier about being able to square root this one. I can square root this one. But my middle term must be 2 times 8 times x, and it is not. This is not a perfect square trinomial. As a matter of fact, this is not factorable at all. Sometimes the trinomial will be factorable by the x method, and you just have to check it out. But it won't be a perfect square trinomial. All right, let's take a look at this one. Now, notice right away that this has got an x, and this has got a y. There's no y here. This is not a perfect square trinomial simply because this y creeps in here. If I were to square root 9x squared, I get 3x. If I were to square root 64, I get 8. And if I multiply that by 2, I'm going to get, not even get that, but 6 times 8 is 48. That doesn't work either. But even if this were minus 48xy, wouldn't work because I would need 48x. Okay. And this one's not a perfect square trinomial simply because the last term's a minus. And you can have that.